they actually get it for free if they want to earn money on it. So if we can put a copyright on it at the same time, and for commercial use we can actually take a license, then the two don't actually collude, because you can actually you can give out things for academic research, to further research, and at the same time you can also make a bit of money on it if it's going to be used commercially.
Tim, did you have a point before?
Yeah, well, no reply to that actually, because I don't like this split between academic and commercial, because after all, commercials, if they make money out of something, they pay taxes, and the taxes come back in. And sometimes you worry about transaction costs for scientists not being able to reuse things, and so we have academic exceptions. But you should also worry about commercials not being able to reuse things. I mean, the mapping example I gave before, by making the maps free, you encourage a lot of commercial operations, who you could argue can also buy the maps, but it's the transaction costs which inhibit them from, setting the right price. So the economic analysis says that actually, if you set the price to zero for everybody, the economy does better in general. And then this idea, this charging the commercials differentially, isn't actually a very smart thing, because then it disincentivizes them from doing something creative.
Can I make the comment that I would differentiate then between commercials using it for research, because commercials using it for further research is free of charge, but if commercials use it to actually make more money on it, then I think it's quite fine for them to actually pay a license. And if we're talking about particularly software, the amounts that they would pay for, Smart A or whatever else, we're talking about 5,000 to 10,000 euros, and if that is what is going to kill a large pharmaceutical company, then I think we have another problem.
Well, again, you will get back the money through taxation, and it's not the very rich pharmaceutical, it's the small people who generate some small business around that, which then becomes important and drives innovation forward, and then they can charge, but they don't do that initial innovation because the charge is too high.
Yeah, so we're basically back to the iPhone and the application model of actually saying, write apps, put it onto the web. Apple is going to actually see, which ones are good, and some of them you can actually charge. But that is a concept, and that is fine, and it's very specific also for, let's say, for the IT branch and also for bioinformatics, because bioinformatics actually thrives on a lot of other people adding lots of little bits to what they have done. So that is completely different to other parts of biological research, where you don't always have this exchange and adding on and writing those scripts and using the same algorithm.
One last response from Tim, if you want, then we move on to Halvor. Okay, Halvor, please.
No, I just comments on the price model as an idea for the funding of science. I can very well understand that this may be very practical and useful, for example, in trying to develop cures for so-called poor diseases, for example. You actually mentioned that. But otherwise, in other areas, there is the question of who is going to, or how is society going to decide on what should be singled out for the sort of a pricing. And secondly, what I was left a little bit wondering was the sort of winner-take-all. I mean, many of you may know how architects function. I mean, often they take part in these competitions and they work for months and months, and then only one team gets the project, and all the others, the work of all the others is lost. And if in science you would have 50 groups or so working towards or related to one of these areas that would be singled out for a prize, and what happened, how would one go about sort of compensating or maintaining the work?
So, all right, so I could talk for an hour on price models.
You can have 5 minutes. These are very important points, and I believe Tim will have points to make in turn, so let's go for it.
I was trying to remember what the first one was.
Well, the first one is this thing about,
how do you decide?
How do you decide?
How do you decide, and how do you distribute when it's not just a single
deciding is pretty easy because we have systems in place. The NICE model, for example, in the NHS decides which drugs have enough value to fund. The Australian NHS system does the same thing. In fact, you'll find that a large number of countries have mechanisms for deciding the value of a medicine, how innovative it is. There's quite a lot of data there. So in fact, I think, there'll be controversy just as there is controversy right now, but it wouldn't be any different. I mean, I think what I haven't gone into is just how inefficient the model is right now. There's lots of data on this. Surveying FDA data over, I think it's 10 years, 75% of all new registered approved drugs have no additional clinical benefit. Now, not only are you paying for those because you're subsidizing the research that led to this is Me Too drugs, but you're frequently doing worse because if you want to approve a Me Too drug, you have to do a larger clinical trial because you have to show that it is as safe as the existing drug on the market, which of course has phase 4 surveillance data. So, there's obviously sometimes it's useful to have an additional drug with a slightly different specificity, but you can see the efficiency there. According to returns, tax return data, drug companies spend 15% of their total expenditure on research. Once you pare that down with the 75%, they're only spending 2 or 3% on actual new research. So you can have inefficiencies in the prize model, but they've got to be really bad to be worse than the existing model. Right? So that's this business of, can you allocate? I think there's enough things about allocation. Now, in terms of how do you give the money out, this is mechanism design. It's really game theory. Like allocating the spectrum, the games that were played by different European countries to distribute the spectrum and have competitions around it. There's something similar to the prize model called advanced market commitments, which in fact Gordon Brown supported at G7. There's a 1.5 billion, I had it up there on AMCs. This may be more appropriate to things like vaccines, where basically you're saying, if you develop a vaccine for X, we guarantee to buy this many units at this price. Now, the only real difference then is, do you then have it licensed so that anybody else can follow on and manufacture? But there's a problem there because you're defining something, you're trying to set the price. What's the right price? Maybe 1.5 billion means nobody tries to develop something. Maybe it was really easy and we should only have offered 1 billion. It's hard to estimate that economically. So what we're advocating is a prize fund, which is rather different, because then you can differentially allocate between all the things that come up in a year, and that should equilibrate. So if it's too easy to get a prize, then you'll get new entrants into the market trying to develop things. Because obviously you'll get prizes over a period of time, and your success rate, if you're a bad pharmaceutical, you don't get any prizes, just like you don't develop any drugs and you don't sell anything. There's no difference really. So if there are too many people in the market and there's not enough money for them, some of them will go out of business, but that's no different from the existing model. So you can titrate, the prize model should titrate the market for innovation.
Yeah, but there was one example that you mentioned, that you showed on one of your slides, the so-called X prize.
That's a rather different thing.
Yeah, but
the X prize is
an example.
Yeah, the X prize is a very different thing because it really is a kudos prize. And people get confused about this. I'm not talking about a prize like in a medal. I'm talking about a genuine reward that matches the expenditure you put in on average in terms of development. So the estimate is for an $80 billion prize model in the US market. And you can still estimate from that, you would save $150 billion per year in the US market for drugs, because you'd basically be switching to generic manufacture, and you cut down all the marketing costs. You wouldn't be marketing anymore. You also get interesting effects such as, if I've got a drug here and then a new person comes along with a better drug, I want to stop selling this one immediately because people should be taking this better drug. But of course, right now,